iodide, okay? But what gets a little bit confusing is it makes iodine, okay? And that's the I2 minus, or excuse me, that's the molecular I2. Peroxydisulfate, you're probably familiar with sulfate. It's SO4 2 minus. Peroxydisulfate is S2O8 2 minus. Okay, so that's the reaction of interest. So just for kicks, let me go ahead and say we know the rate of this reaction. You guys are going to be watching it. Is equal to some rate law constant K times the molar concentration of I minus raised to its reaction order. And guess what? You're going to find what that is graphically today. Times the molar concentration of the peroxydisulfate, S2O8 2 minus, also raised to its reaction order, N. So today, let me go ahead and just get the chemistry out of the way. All right, so that's that. Now there's a second reaction that occurs right away. So I'm going to put the word quickly right next to these two reactions. The reaction of interest is the top one, but the other reaction actually is required for us to judge you'll see what I mean. So notice that the I2, the iodine in the reaction of interest actually goes to that second reaction. The thiosulfate, S2O3 2 minus, is in limited supply. Okay, and it'll be the same amount in each of your 8 trials. You're going to do 4 trials and 4 trials. The thiosulfate is the same everywhere, okay? So here's the deal. The chemistry looks like this. When the thiosulfate, which is the same in all 8 trials, when it runs out, what's going to happen is basically your solution is going to turn from maybe cloudy to blue. So you're looking for a blue color. So bottom line, these 8 trials, you are going to look for the same consumption of the thiosulfate, right? So kind of the nuts and bolts of what you're doing look like this. Let's see. Let's just go ahead and go to the experimental section. For me, it's on 243. Okay. So in here, and we definitely have 2 groups going on, right? Here are your, these will be what you need for one set of trials. So you can see that basically you are going to get a pair of solutions that somebody's going to have a stopwatch ready. You're going to go over to a 50 ml beaker that's on a white piece of paper, pour them together, start the stopwatch, and look for that blue color. Okay. So for instance, in this one, okay, this is 1A. This would get 8.0 milliliters of I minus, and it would also get 4 milliliters of your thiosulfate. Okay. This one would get 8 mils of your peroxydisulfate solution. See how that works? Okay. If you add 8 plus 4 plus 8, you get 20. In each of these, when we pair them up and dump them together, your solution's going to have 20 mils there. Okay. So just this is one where you don't want to. You want to just have a clear mind. Go ahead and make sure you get your solutions. Make sure you get it right. Your instructions say go ahead and grab 3 50 ml beakers, cute little beakers. If you need some more, there definitely some, I think, behind the screen there. 3 50 ml beakers. You want to label what they are, because over here, these two are kind of together. These go in your A's, okay? These are the 2 things that go in your A's. This goes in your B in various amount. Notice in your B also, you're supposed to have some kind of makeup water sometimes, okay? So sometimes B gets water. Are there any questions about that? Okay, I think you guys will do great. So like I said, once you have these ready to go, very carefully, because you don't want to do it twice. Okay, if it doesn't turn blue-black, something went wrong. Okay, once you have your set, your A and your B ready to go, go ahead and dump them. And I think it might say, let's see, it doesn't say stir or anything. I think the first one takes about 40 seconds, so it's coming. Notice that, let's see, if you look at for the first 4 set, look at your peroxydisulfate. That's what's varying. Your I minus is constant. Notice that we're getting less and less peroxydisulfate. What should happen to the reaction rate? Should it go faster or slower? What do you think? Will they be more or less likely to collide if there's less concentration of that peroxydisulfate? Less likely. Yeah. It's going to slow down. Okay, so we'll see if that happens. So that's that. Then you go ahead and between your between your dumpings, you just go ahead and dump out your 50 ml beaker down the drain, rinse it out, wipe it down, and use it for the next set, okay? So once you're done with that, go ahead and rinse these out, and you're ready for the next set of runs, which, not so surprising, the next set of runs, notice you hold the peroxydisulfate constant, and you vary the I minus from high to low. Okay, so just kind of, like I said, kind of make sure you do this right. So let's look at the calculations. And I will push these out there. I'll tweak them. So my calculations, excuse me, we have to, it's a kind of a long story, but we kind of have to go back first, all right? So your first calculation is to calculate the thiosulfate. That was the thing in the, not the reaction of interest, but the thing that's there in limited supply, okay? And you can use M1V1 or C1V1, same thing, is equal to M2V2, okay? You can definitely use that. So in this case, you just need to get the molarity of the thiosulfate off of the bottle. So that's the molarity of the stock. You're going to use 4 mils, you know, on these, both of these things I looked at. You're using 4 mil aliquots, okay, in each time of that. So, by the way, over there I have the standard, the pipette bulbs out, so pick your favorite pipette bulb, and then I have the graduated pipettes to use. All right, so calculation 2. Calculation 2, you're supposed to get to the I2, and you're going to use the stoichiometry from the thiosulfate, okay? Thiosulfate, 1 concentration. The I2, the iodine, okay, molar concentration is also the same for all 8 trials, okay? So I kind of went ahead and did that for you. The next one is to go ahead and turn your attention to your raw data. So remember, you have a time. You basically will record a time for each trial. For each trial, for the first set where you varied the molar concentration of the peroxydisulfate, you have to come up with the initial concentration of the peroxydisulfate for each trial. Okay, and again, that is actually using basically M1 times M1 times V1, where that V1 is the volume, divided by M2, that's the total volume in your beaker, is equal to what your concentration of your peroxydisulfate is. So you'll need that for the 4 trials. Okay, and then calculate each rate. So to get the rate, we're going to take that single number that you got in calculation 2 and divide it by your 4 different times. So we'll have 4 different rates, and we think it should get slower. Okay, so that's your rate. Then you're ready for Logger Pro. You're going to take the first 2 columns in Logger Pro is your data. The green columns here is the data, the things you're going to have Logger Pro calculate. So by now you know the initial concentration peroxydisulfate for all 4 trials. You know the reaction rate for our 4 trials. The green there says take the log of the peroxydisulfate molar concentration, take the log of the rate, and those logs actually you can see on the little black graph at the bottom there. Those logs are what you're going to plot. So we're going to plot the log of the rate on the y-axis, the log of the peroxydisulfate on the x-axis. So we're going to have 4 points. We're going to see how linear they are. That's okay. We're going to have 4 points, and the slope of that curve then is equal to the reaction order of your peroxydisulfate. Pat yourselves on the back. Okay. So we already did this slide. Oops. All right. So calculation 7 then turns your attention to your second set of 4 trials where you vary the iodide molar concentration. Okay, so remember your I minus is its own little entity. It's in that first bottle over there. Get the molar concentration of the stock, and you can knock out each molar concentration of your I minus that is in your beaker. Oh, really? Come back here. You are evil. So the next calculation is coming up. And we're going to have to fast forward through these. That's pretty good. All right. Oh, all right then. Calculation 8 says calculate the rate. Again, kind of like you calculated the rate for the changing the peroxydisulfate now. Calculate the rate for changing the I- concentration. Again, go back to that I2 concentration, which is the same for all 8 reactions, and divide that by the time you got for that second set for each trial. Number 9 again, Logger Pro, you're going to have 4 columns. The first 2 columns are your data. The last 2 columns are, did I switch from natural log to log base 10? Oh, that's okay. So I'll go ahead and tell you what I mean to say. This actually, you could do natural log, but we're going with log base 10. Sorry about that. Okay. You'll have 4 points on there, hopefully get a nice straight line. The slope of that is going to be the reaction order of your I-. Okay, why is this not? There it goes. Okay. And then I said, whew, oh my gosh. So what you just did so far is come up the reaction order for first your peroxydisulfate, which is N in this case, and then your I-, which is N here. So now you know those little superscripts. So now we're ready to go for K, basically. All right, so 5 and 6, I don't know why they say. They should, like, they didn't go in order there. So what says 5, and again, it's on my page 247, really follows 10. Go figure. Okay, but in either case, basically you need to revisit your data, and you need to, where you held the I- concentration steady in your first 4 trials, you need to knock out what that concentration is. You can use M1V1 is equal to M2V2 if you want to. That'll be the same. And then similarly for your second set of trials, you need to come up with what that constant molar concentration of the peroxydisulfate was. Then you're ready for Logger Pro. And everything in red here, you kind of see 8 lines. There's supposed to be 8 lines there. So you'll have 8 trials, and you already did the reaction rates. So jot those down in the first column. By now, you should know the initial concentration of peroxydisulfate for all 8 trials, the initial concentration of the I- for all 8 trials. Okay. Then you're ready to basically plug into the I- raised to its reaction order, the S2O82- raised to its reaction order, because you got M and N earlier. Okay, so let Logger Pro spit that out for you. And then you're ready for your last plot. So in class we talked about yesterday that in this case, if you take just the plain old rate, not the log, but the just plain old rate along the y-axis, and along the x-axis, if you take the molar concentrations raised to the reaction order, you should get a straight line with a positive slope. In this case, the slope is equal to the value of the rate log constant K. So there you go. And so like I said,